cool. So today I'm talking about, so actually today it was supposed to be Java Ref, but I looked at the old slides, it was only 12 slides. I threw Android there as well because, as we'll get into, Android is pretty much just a Java wrapper, but they made it more fancy and faster, so there's that. So announcement, tomorrow, our first CTF, LA starts at 10 p.m. local time because the LA people are jerks. And
10 p.m.
yeah, 10 p.m. tomorrow. And there are many beginner-friendly challenges available, hopefully. So there's that. Yeah, so that's the meeting flag. I think Cameron already put it on, or okay, you did that. All right. Does anyone know what this is referencing? Because I do find this pretty funny. Or am I like too old of a Java generation? I don't know.
Whenever you update Java on Windows, you hit the Java updater window, they always put running on 3 billion devices worldwide.
Yes, and in 2022, they updated their website to say that now there are 56 billion devices running. So this is a reasonable extrapolation of that. Anyway, yeah, I mean, just loading. So just an overview. So first you have your Java source file, you write your code in Java, and you compile into bytecode, which is pretty much lossless, as we'll get into. And your JVM interpret those. Actually, no. So your JVM does a just-in-time JIT compiling of the code before it runs the code. And so JVM is actually developed in many platforms, so it allows this same Java code to be run on many platforms. So that's kind of the idea of Java. So like there's little compilation to be done, and most of it is really just the JVM doing heavy lifting. So yeah, .java files are just source code. .class files. So one Java file compiles to one class file, contains JVM bytecode, use Javac to compile. Jar files is just a zip file with a collection of class files and some metadata. So these metadata contain stuff like, you can have external assets that are in there, certain indices, like which file does your program start, right? Where do you look for the main function, and among other things. So, you can so JVM takes in a .jar file and it just executes it, something like that. Yeah, so as you can see, a lot of the metadata is stored in manifest.mf. And so Android took a page out of Java's book because probably at the time Java was popular, right? So it says like, okay, we're gonna do things similar to Java. So Kotlin, which is new, language for that, also compiles the class, among other things like JavaScript, which is really cursed because they implement an old standard. But I think the mainstream use of Kotlin is still, Android development. So by extension, it can compile to similar things as Java and can be executed on JVM. So we're just not going to talk about those cursed applications that they came up with because it's fine. So APK, as we all know, this is what you install on your Android phones, right? So originally it extends from jar, but now it's some format. There are some slight differences. Jar is kind of like a wrapper. APK is almost like a wrapper for jar now. But anyway, so again, I would have to assume that zip was a big thing back in the day because all of them are just zip formats. It's a fancy zip format with similar metadata folders, as you can probably look at the structures. They also have a resources folder with a bunch of things, an access folder with a bunch of things. If you're interested, you can look it up. But instead of many .class files under a structure, like in Java, you have com dot blah 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 dot whatever. So the Java's cursed way of managing resource code. Instead of that, you just get a single .dx files. DX stands for Dalvik executable, which I still don't know who that guy is, but it's only used by Android. So use your DX tool to convert your class files into one DEX. So you can think about one DEX as also kind of a zip almost of all the .class files, except I don't think it's a zip. It's just a collection, a compressed file. So that makes it really interesting because technically the bytecode are compressed twice in the APK file, which is like, I guess it's efficient, but whatever. But in any case, because DEX is really similar to JavaScript, you can go one way pretty much losslessly. So that means you can also go the other way pretty much losslessly, right? You can just use open source tools like text2jar to pretty much just compile to jar, and then you can, actually, unzip it and figure out the content inside. And just one more note, this is from personal experience, but I think like index files, it even contains more information than jar files, which we'll get into later. Anyway, so JVM and DVM, that's what they're called. So JVM is a stack-based virtual machine because x86, hooray, everything's on the stack. That's why we have ROP. Anyway, so I guess this is what they did. They took a page out of the x86 book. So everything stack is stack-based virtual machine. So if you look at how the bytecodes are represented, you'll see a lot of push and pop to interact with the stack, right? So all instructions take arguments using push and pop. This is the same as x86. JVM for all platforms exists to run Java on 3 billion devices. Of course, as we all know, 3 billion devices. Yeah, so that's what allows you to run bytecodes everywhere. Very easy to compile, but also very easy to decompile, which we'll get into later. So the DVM actually, I think this is what, because Dalvik, like DEX, Dalvik format, and DVM only exist in the space of Android. And Android pretty much exclusively run on ARM, which is a RISC instruction set, and it has a lot of registers, and so we don't have to do all the stack stuff anymore. So actually DVM, although it's executing something like similar bytecode, but it's actually a register-based virtual machine. So actually DVM is the old form. It performs just-in-time compilation, but then Google looked at it and be like, we're gonna install this app anyway. So why don't we compile the thing at install time? So every time we execute, we're just gonna execute whatever is compiled at install time. So they come up with Android runtime. So Android runtime pretty much just means, oh, you compile this thing for once and then you just runs it on your device forever, kind of deal. But again, like this got me curious. Why not just compile to ARM assembly? I'm not like, of course, I don't know, ARM or Android, the architecture on things, but I just think that this is kind of an interesting legacy that they just compile to, DVM or whatever instead of just compiling to ARM assembly, because I assume it will be universal. Again, if any one of you are a Android dev, whatever, can answer that, that would be great. But if not, I can just move on.
So basically, Android, can you explain? Sorry. So Android basically does sort of the same thing where it compiles it once and then how does Android's like DVM compilation compared to the JVM?
So I mean, in JVM, it does a JIT compilation. So because it's JIT, anything that's produced by the compilation process is strictly exists within JVM. It's not like you can export it or something, right? So it just runs and then you're just getting the outcome and you're happy, right? But for DVM, it does the same thing, but then Google looks at it and being like, that's too inefficient. So Google actually split it up in two parts, right? So it compiles beforehand and then it runs it. So it further compiles, you can think about it as a Java bytecode or bytecode by that matter. I don't know if it's strictly Java bytecode.
Java.
Yeah. So basically, Java does the optimization within the JVM, whereas Android optimizes beforehand and then runs it, so optimize it once.
I see.
But it's still really cursed. I mean, this is all like a very legacy tech stack. If you think about it, Android 4 came out like 2010 or something, probably even earlier. So, So Java compilation. So the reason why I said it's pretty much lossless and pretty much just not really a real compilation is because you can keep class names, function names, class variable names, and line numbers for stack trace printing. So imagine if it like segfaults or whatever. I know segfault is a very C term, but I'm still gonna use it. So imagine if a segfault is gonna give you a line number being like whatever. I don't know if you can strip it, like you can strip a binary, but by default it keeps all of these. So if you can just like if you just put it in a software, it can just get all of these information and pretty much just recover your code. You only lose local variable names because, as I mentioned, it's stack based. So it's just a position on the stack. You only know its size. You don't know its name. Java doesn't keep track of that. So you'll see a lot of local numbers, whatever, and comments, of course. No compilation process keeps comments. So I believe this is also a similar story with DEX, but in my personal experience, DEX actually keeps more data, and so basically it'll come out cleaner. That's my impression. There is one Java rev on our website. I mean, one Android rev on the website that you can see, but yeah. So to decompile, just very simply, you can find a plethora of tools online to decompile these. Like this is by no means an exhaustive list. I can at least I can find like 5 or whatever, all of which are open source. You can probably even find more because there are so much information. So pretty much anyone with like half a brain cell can write a decompiler, something. So if you're decompiling Java, you can use JDGUI. This is my personal preference, but Bytecode Viewer is also very good. It comes with two decompilers. ASM Tools, which is a tool provided by OpenJDK, so it's kind of official, but yeah. But it only comes with a command line disassembler, a plethora of other things that you can imagine. Again, now we have like AI, right? So I know that there exist decompilation tools for Python bytecode that uses AI. I don't know if there exists similar things for Java, um, but you can probably find some online. And for DEX, JDX actually displays things very, very, very neatly, and I really like that. APK tools. Actually, Ghidra can take in APK format, believe it or not. So you could also use that. Dex to jar, as I just mentioned, you can trivially convert Dex into jar. So just convert to jar and then do all of that. So the left one is the JDGUI, and then the right one, I believe, is JDX. So as you can see, the decompilation process, at least the result of it, is really clean, and most of it will actually try to autocomplete the variable names for you. So instead of Ghidra being like, oh, this is local, whatever, this is DAT, whatever, you get somewhat of a nice variable name, at least. I believe some decompilation tools are also built into JetBrains, like the Java whatever developer environment IDE. I don't know why, but it just know it's built in, and there's many tools that you can use. So of course, we have to talk about obfuscation in terms of these kind of things, because generally obfuscators can do a bunch of things to basically mess up the decompilation process, right? So you can think about it like change the control flow, rename everything, scramble everything, remove or add functions, encrypt strings, right? So similar to LLVM obfuscators, this is also present on many of the obfuscators. So these are some popular obfuscators, but I believe all of these three are closed source. You can probably find some like pirated version online. Of course, I'm not suggesting that you should use them, but there are also many open source options that you can use. Additionally, if you really want, I mean, the bytecodes are all there. Just write your own scrambler, just learn Java. And Android Studio actually comes, I believe, natively with an obfuscator, which is understandable, right? You don't want anyone to just rev your Android application, so they do that. And again, there are a bunch of other stuff that can be obfuscate APKs. I think in this context, honestly, obfuscating APK is more important than obfuscating Java code. Although nowadays, I suppose APK is more important because Android still exists, but Java, I don't know who writes Java anymore. So Anyway, yeah. I mean, imagine one day it actually goes down from 56 billion devices back to 3 billion devices. I mean, I'm sure this day will happen. I just don't know when. Anyway, so deobfuscation. Obviously, try different deobfuscators, right? Because obfuscators will obfuscate code in some sort of pattern, right? So like scrambled variable names, you can just simply rename them. Certain control flow stuff, you can kind of see the patterns and kind of bring them back, but not really. Many of which are also open source. You can kind of see how they operate and you know attempt to deobfuscate things. Especially also with string encryption, right? So string encryption is usually done in the same way, so you can just decrypt it and reverse the whole process. But still, as I was saying, you can rename things, but the original names are still lost if you're just given the Java file. So many deobfuscators available. You can use the ones I linked for starters. Also, Nathan's tutorial is there. This was recorded in 2020. If you want to see some of the legacy stuff, feel free to go there. I think he did a good job at explaining like how to actually use these tools. Like this is also a snippet from his recording. So you can see the original is just a very simple, oh, I'm just gonna print hello world like 5 times, right? But after obfuscation, you can kind of see that the string is broken up and you are actually printing one character at a time, which is being obfuscated. And you can see there's a bunch of garbage down there that's added, right? Because you can just add arbitrary amount of push and pull, like push and pop instructions without affecting much of the program's functionality as long as these are consistent. So this creates a bunch of garbage local variables. So I assume that's how you do some of them. And of course, this is not complete. There's also a bunch of other garbage down there, but just simply put, like this is basically the hello world but obfuscated, and they're doing stuff out there. And by just running it through a simple deobfuscator, we can see that the loop structure has changed, but the function remains, and it completely deobfuscated this string. So I guess it's somewhat useful still. But if someone has to do with, but if someone applies custom obfuscation, I mean, this is pretty much true for all the obfuscated challenge. There's not much that you can do, if like because you don't know how the pattern works. So either you can use object web ASM to manually parse and manipulate bytecode, or I guess view bytecode and try to make sense of it, like just raw bytecode. You can also, again, this is like highly challenge dependent. I haven't seen like a Java challenge for a long while for obvious reason. Nobody's using Java anymore. So there's that. Java standard is also constantly updated. I believe it's up to like JDK 24, something like that. New constructs like invoke dynamic can create new operators. This is a challenge write-up, something like that. But also like just the new Javas have added quite a lot of new features actually. If you guys are interested in Java dev, obviously feel free to check out the documents, feel free to check out new Java challenges. But yeah, worst case scenario, just do it as assembly, right? Because bytecode is still arguably easier than x86 assembly where you push off a lot of stuff and you don't notice the data size and whatnot. So yeah, this is a challenge on PwnyCTF, Java Rev Suite, and DroidFont, because I grouped them together. And so next Thursday, crypto block cipher with SACNIC, learn how to exploit AES. It's actually pretty fun. You can see some shortcomings of the AES. And next Sunday, SIG policy collab, which I don't know what the content is. Maybe are you going to talk about it?
Oh yeah, it's cyber warfare. We're talking about cyber warfare.
Okay, we're going to talk about cyber warfare. And
Policy, with that as well. Policy. We also have things like cookies SP reader. So is Ryan have with you? Well, that Ryan is Ryan coming in? Ryan, I don't think he is. Like we could ask him. But he just told me SIG policy leads like
Yeah, so that would be great. Anyway, that's it. There's nothing much for me to talk about Java. That's pretty much it. Anyway, that's the end of the meeting.